Okay, so here's our last video. It's going to be covering multi-step problems. A multi-step problem is where you start off on one of the outlying areas, you go through Mole Island, and then you go to the other one. So let's say that we have our Mass Island here, and in the middle we'll have our Mole Island. We'll have Peter Volume Island here. We can do FU Island here, and let's say Total Atoms. So looking at these and where they are and how they're connected, um, you can see that we can go from Volume Island to Mole Island, and we do that by taking the 1 mole divided by 22.4 liters and multiplying that to whatever number we are given in the problem statement. We can also go from Mole Island to Volume Island, and we would do that by taking 22.4 liters and dividing that by 1 mole. Whatever we get as a result, we will multiply to the number that we're given in the problem statement. We can go from Mass Island to Mole Island, and we do that by taking the grams of the molar mass. By taking 1 mole on top and the grams or molar mass in grams bottom. We can go the opposite way from mole to mass and so forth, right? So the thing that you should see here is that we're always going from one of these outlying islands to Mole Island, and then if we wanted to go to Mass Island from there, we'd have to go through Mole Island. Pretty much any conversion factor or any conversion between units that you want to do has to go through Mole Island if you're going to do 2 steps. Or it has to at least end in Mole Island if you're going to do 2 steps. Let's say, let me clear this up. Let's say that I wanted to go on a multi-step trip between Volume and FU Island. So I'd start off in Volume Island and I would convert my moles. And then once I had my moles, I would convert to formula units from there. So it is one conversion and then a second conversion. And it's basically doing my volume to mole conversion, getting an answer, and then converting that answer in moles to my formula unit. If I want to go further from there, I could go all the way to Total Atom Island if I had a multi-atom molecule and I wanted to say, no, how many atoms of copper are there in 36.7 liters of this weird gas? Something we could certainly do, and there's a lot of reasons to do multi-step problems, but we should probably just get some examples started. First question says, how many molecules are in 57.3 liters of CO2 gas, so carbon dioxide? We are starting off on liter island because the number that they give us is 57.3 liters. So that is volume island. And to get to where we want to go, which is FU island, we need to go from volume island to mole island, and then from mole island to the formula unit island. So if I start off by writing my 57.3 liters of CO2 gas, I'm going to actually write 57.3 liters CO2. And there's a reason for that, and we won't really see it until maybe another problem for now, but it's pretty important to actually include things like CO2 at this point when we do the multi-step problems. So I have my first boat, and so I have 57.3 liters of CO2, and we are going from volume to mole island, so moles go on top. I will put 1 mole of CO2, and down below I will put 22.4 liters CO2. So my liters of CO2 will cancel, and I am left with this 57.3 divided by 22.4 liters, and my answer ends up being 2.56 moles of CO2. Now I've done my first conversion, so my second step would be to take my my answer, which is at 2.56 moles of CO2, and then I convert that from moles, so we're leaving Mole Island now, and we are going to FU Island. So if we do that, we have to take our 6.02 times 10 to the 23rd. That's that Avogadro's number. And this will be molecules. 6.02 times 10 to the 23rd molecules of CO2 divided by 1 mole CO2. So my units cancel on the top and bottom, and I am left with just these molecules of CO2, which is what I want. And the answer I get for that is 1.54 times 10 to the 24th. I would have molecules 1.54 times 10 to the molecules of CO2. That's awesome. That's how we would do a multi-step problem, and we can do this both these steps at once. How we would do that is I would take my 57.3 liters of CO2, and I would do my first boat. So just like my first boat was 1 mole CO2 divided by 22.4 liters of CO2. And then I would multiply that by my second boat. So I'm taking my first number, my first boat that converts from moles, or sorry, from liters to moles, and then I'm adding to that, or not adding, but I'm multiplying all this together. And the last boat that I will need to take is that one that has 6.02 times 10 to the 23rd molecules, abbreviated MOLEC, molecules of CO2 divided by 1 mole CO2. So down in this division, I have, in the bottom of that division, I have 1 mole CO2. And on the top of this one, I have 1 mole of CO2. And so those cancel. Down in the bottom of my first boat, I have liters of CO2. That cancels the liters of CO2 I started with. That just leaves me with units of molecules of CO2. So when I do this whole multiplication in my calculator, I take 57.3 times, parentheses, 1 divided by 22.4, close parentheses, times, open parentheses, 6.02 10 to the 23rd, and then close parentheses, file that together. And I would still get this 1.54 times 10 to the 24th molecule 2. All right, so how about how many grams are in 3.44 times 10 to the 24th molecules of MgOH2? Well, this is one of those ones, because it's mentioning grams, we're going to need to convert from grams to moles, and so we will need our conversion factor, is the molar mass. So the molar mass of this one, have magnesium, Mg, at 24.31 grams per mole. I have oxygen at 16.00 grams per mole. And I have hydrogen at 1.01 grams per mole. I know how many atoms there are. There's 1 magnesium, there are 2 hydrogens and 2 oxygens. Remember, our polyatomics are protected by this parentheses, and so we take the 2 and we multiply it into here. That's 2 times 1 gives me 2 oxygens. 2 times 1 gives me 2 hydrogens. There are 2 oxygens, 2 hydrogens, and 1 magnesium in this molecule. So to do my molar mass calculation, I take 1 times number of magnesiums times the molar mass of magnesium, 24.31 grams per mole. And I add to that the number of oxygen atoms, which is 2, times the molar mass of oxygen, 16.00 grams per mole. And then I will add to that the number of hydrogens times the mass of hydrogen, molar mass, which is 2 times 1.01. And I plug this into my calculator. Well, I get 58.32 grams per mole. This is for our magnesium hydroxide, OH2. Okay, the next thing that I need to do is start off by converting. So we are starting off in FU island and we need to go to mole island. So my number of molecules of my number of FUs of MgOH2 is 3.44. That up a little bit. A different color too. 3.44 times 10 to the 24th molecules of MgOH2 times, so I do my first vote, is times 1 mole. We are going to mole island from FU island. On the bottom of our FU island will be, sorry, on the bottom of our boat will be that 6.02 times 10 to the 23rd Avogadro's number. And that is the molecules of MgOH2. These units will cancel molecules of MgOH2, and then we will have left over 1 mole of Mg. We will have left over units of moles of MgOH2. When I do this division, I get somewhere around 5.7 moles of this MgOH2 stuff. All right, so now I know how many moles there are in this 3.44 times 10 to the 24th molecules of MgOH2. That is 5.7 moles. I can convert my 5.7 moles of MgOH2 into the number of grams. And do that, I will take my, so we want to go to mass island. That means our grams go on top. 58.2 grams of OH2 per 1 mole of MgOH2. You don't need to actually include the molecule. I do this because if we convert to total atoms, it's often useful to see that we're going from a number of molecules of MgOH2 to number of atoms of magnesium or something like that. It's easier to see that when we do those types of conversions, but it's not, entirely necessary. Anyways, our 1 mole of MgOH2 will cancel out our moles of MgOH2 from our problem, and then the answer that I get is 332.42 grams of MgOH2. That's a lot of writing. There's a lot of work involved in that. Maybe a simpler way would be to just kind of chain our multi-step processes together. So here, if I start off again with 3.44 times 10 to the 24th molecules of OH2, or MgOH2, I'm just going to molecule, I'm going to write out everything. And I use my first conversion factor, which was 1 mole divided by 6.02 times 10 to the 23rd. Molecule. And then I multiply my second conversion factor to that, I get 58. Or I put 58.3 grams on top, 1 mole on the bottom, and then my total answer once I do all this multiplication, which would be that 3.44 times 10 to the 24th. And remember, put that in parentheses, divided by, again, parentheses, 6.02 times 10 to the 23rd, and then multiply that by 58.32, I will get 332.42 grams. Either way works. It's just that this painting process actually usually ends up taking up less space on your paper, and sometimes once you get good at it, it becomes faster. But by all means, if you feel more comfortable doing one conversion and then a second conversion, that is absolutely fine too, as long as it gets you to the correct answer. So, all right, so that is all that we have covered for this entire unit. We will have that summative tomorrow afternoon, and I hope that everybody does well, and I hope everybody found this stuff helpful. So, good luck.